Panic thrives on noise. When you encounter a complex chemistry problem, the instinct is to react to the clutter and rush through the data. But power is in the silence that precedes the work. It's the decision to stand still while the variables swirl around you. This is the Nernst equation. It maps the relationship between electrical potential and ion concentration through three specific controllable variables: the standard cell potential, the moles of electrons, and the reaction quotient. To navigate this, you don't attack the formula as a single block. You move through it variable by variable, isolating the components into their own workspaces, where they can be solved individually. Solving an intimidating problem isn't about raw speed. It is about refusing to let the volume of information overwhelm your process. Look at this standard electrochemical problem involving copper and silver. The different concentrations are designed to trigger a reaction, hoping you'll overlook the details in a rush to find the answer. The first operational step is finding the standard cell potential. We set up the subtraction, cathode minus anode. By writing the values out clearly, 0.80 minus negative 0.34, the math resolves to a positive 0.46 volts. Now we move to the second variable, N, the moles of electrons. If you guess this number to save time, you give away control of the problem. Instead, we write the half reactions. Copper undergoes oxidation, silver undergoes reduction. By balancing the two reactions, the electron transfer becomes visible. 2 electrons move through the system, so N is confirmed as 2. When you prove the variables with written evidence, the problem loses its ability to confuse you. You are building a case for the final answer. The final piece is the reaction quotient, or QC. This relies on the balanced net ionic equation we just derived. Here is the critical rule. The concentration of the ions must be raised to the power of their coefficients. In this case, the silver ion concentration is squared. All the raw materials for the final calculation are now gathered and verified. Pause the video here, silence your environment, and plug these three values into the Nernst equation yourself. Taking this moment to pause is a demonstration of power. You are choosing to move at your own pace rather than the one dictated by the exam clock. We face the final calculation. Intimidation often comes from negative exponents inside a logarithm, but the rule is consistent. The log of 10 to the negative 5 simply becomes negative 5. Once neutralized, the arithmetic flows to the final voltage. To repeat this result, follow the sequence. Isolate the standard potential, balance the half reactions, apply exponents to the quotient, and execute the math without rushing. Dealing with a complex equation is an exercise in composure. By following the process and isolating the variables, the correct answer becomes the